For centuries, humans have gazed at the stars, dreaming of what lies beyond our home planet, and wondered about life beyond Earth. The mysteries of the cosmos have always intrigued us. Mars, our red neighbor, has always held a special fascination. Its barren, rocky surface and the possibility of water have sparked our curiosity. Could we one day walk on its surface, breathe its air, and call it home? The idea seems like science fiction, but it's becoming more plausible. Today, the dream of living on Mars is closer than ever. Advances in technology and space exploration are making it a tangible goal. NASA, the American Space Agency, is actively exploring the planet with rovers like Perseverance. These rovers are our robotic pioneers, paving the way for human exploration. Perseverance is searching for signs of ancient life, analyzing soil samples and studying the planet's geology, and testing technologies for future human missions. These tests are crucial for understanding how we can sustain life on Mars. SpaceX, led by Elon Musk, is even more ambitious. The private company is pushing the boundaries of space travel. Musk envisions a self-sustaining city on Mars, home to 1 million people by the end of the century. This vision includes everything from agriculture to industry. SpaceX is developing the Starship, a massive spacecraft designed to transport humans and cargo to Mars. This spacecraft is a key component in making interplanetary travel a reality. While the journey to Mars is technologically challenging, the real test lies in surviving and thriving once we arrive. Training and preparation are essential for this monumental task. Mars is a harsh mistress, with a thin atmosphere, extreme temperatures, and a surface bombarded by radiation. Overcoming these challenges will require innovation and resilience. Mars presents a hostile environment for humans. The red planet, with its barren and desolate landscape, is a far cry from the lush, life-sustaining Earth we call home. One of the biggest challenges is the thin atmosphere, which is about 100 times thinner than Earth's. This thin layer of air offers little protection and makes breathing without assistance impossible. This thin air is mostly carbon dioxide, which is poisonous to humans. Without a proper breathing apparatus, survival on Mars would be impossible. Temperatures on Mars are extreme, ranging from a balmy 70 degrees Fahrenheit at the equator to a bone-chilling -200 degrees at the poles. These drastic temperature variations make it difficult to maintain a stable living environment. These temperatures fluctuate wildly between day and night. Another danger is radiation. The lack of a thick atmosphere and a global magnetic field means that Mars is bombarded with harmful radiation. Mars lacks a global magnetic field and has a thin atmosphere, leaving its surface exposed to harmful radiation from the sun and cosmic rays. This radiation can penetrate living cells, causing significant damage over time. This radiation can damage cells, increasing the risk of cancer and other health problems. Long-term exposure to such radiation is a major concern for any potential human settlers. The Martian soil itself poses a threat. It is not just the harsh climate and radiation that are problematic, but also the very ground we would walk on. It contains high levels of perchlorates, toxic chemicals that can disrupt thyroid function in humans. These chemicals are widespread in the Martian soil and would need to be carefully managed. Any attempts at agriculture would need to address this issue. Growing food on Mars would require innovative solutions to detoxify the soil and create a sustainable environment for crops. Surviving Mars's extreme environment will require advanced technology, careful planning, and a deep understanding of the planet's unique challenges. Only then can we hope to thrive on the red planet. Creating a livable environment on Mars is a monumental task. We need to develop habitats that protect against radiation, regulate temperature, and provide a breathable atmosphere. These habitats will need to be self-sustaining, minimizing reliance on resources from Earth. Food production is another major hurdle. Martian soil, while containing some necessary nutrients, lacks the organic matter found in Earth's soil. We'll need to develop innovative farming techniques, such as hydroponics or aeroponics, to grow food in a controlled environment. Transportation on Mars presents its own set of challenges. The planet's lower gravity, about 38% of Earth's, will affect how we move and transport goods. Rovers will be crucial for exploration and transportation, while new technologies might be needed for long-distance travel. Two main approaches dominate discussions about colonizing Mars: terraforming and technological adaptation. Terraforming involves transforming Mars's environment to make it more Earth-like. This could include releasing greenhouse gases to thicken the atmosphere and warm the planet, and introducing microorganisms to create fertile soil. The technological adaptation approach focuses on developing advanced technologies that allow humans to survive and thrive within Mars's existing environment. This includes building radiation-resistant habitats, developing life support systems, and creating closed-loop ecosystems for food production. Both approaches have their challenges. Terraforming is a long-term process that could take centuries and requires a deep understanding of planetary science. Technological adaptation, while potentially faster, relies on developing and maintaining complex and expensive technologies. Water is essential for life as we know it, and finding a sustainable source of water on Mars is crucial. Evidence suggests that liquid water may exist beneath the Martian surface, potentially accessible through drilling. Time is another factor to consider. A day on Mars, known as a sol, is about 40 minutes longer than an Earth day. A Martian year is nearly twice as long as an Earth year. These differences will require adjustments to our sleep cycles, calendars, and overall way of life. Food on Mars will be a far cry from the variety we enjoy on Earth. Early settlers will likely rely on pre-packaged food and supplements brought from Earth. However, for a long-term presence, we need to establish sustainable food production. Hydroponics and aeroponics, methods of growing plants without soil, are promising solutions. These systems use less water and space than traditional agriculture and can be adapted to Mars's environment. Insects, algae, and lab-grown meat are other potential food sources being explored. Maintaining human health on Mars poses unique challenges. The lower gravity could lead to muscle and bone loss, while the radiation exposure increases the risk of cancer and other health problems. Access to healthcare will be limited, requiring advanced medical technology and possibly even the development of new treatments tailored to Martian conditions. Psychological well-being is just as important as physical health. Living in a confined environment, isolated from Earth, can take a toll on mental health. We need to develop strategies and support systems to address the psychological challenges of living on Mars. The psychological impact of living on Mars cannot be underestimated. Imagine a life where you can never breathe fresh air without a suit, where the sky is a dusty red, and where communication with Earth is delayed by several minutes. Isolation, confinement, and the lack of a natural environment can lead to anxiety, depression, and other mental health issues. We need to develop psychological support systems and create environments that promote mental well-being. Colonizing Mars is an incredibly expensive endeavor. Developing the necessary technologies, building the infrastructure, and transporting people and supplies will require massive investments. Governments and private companies are collaborating to fund these efforts, but it remains a significant financial challenge. The potential for scientific discoveries, resource extraction, and the advancement of human knowledge are driving forces behind these investments. However, we need to carefully consider the costs and benefits of colonizing Mars before embarking on this ambitious journey. The implications of colonizing Mars extend far beyond simply establishing a human presence on another planet. It raises ethical questions about our responsibility to preserve potential Martian life, the ownership and governance of Martian resources, and the long-term impact on both Mars and Earth. The challenges of colonizing Mars are immense, but so are the potential rewards. It's a journey that will push the boundaries of human ingenuity, foster international collaboration, and perhaps even redefine what it means to be human. The dream of living on Mars is no longer science fiction. What was once the realm of imagination and speculative fiction is now a tangible goal within our reach. With technological advancements and the determination of scientists, engineers, and entrepreneurs, it is becoming increasingly plausible. These visionaries are pushing the boundaries of what is possible, turning dreams into reality. However, the journey to Mars is fraught with challenges. The vast distance between Earth and Mars presents logistical hurdles, and the journey itself is perilous. From the harsh Martian environment to the psychological impact of isolation, we must overcome significant obstacles before we can truly call ourselves Martians. The thin atmosphere, extreme temperatures, and frequent dust storms make survival difficult. The question is not whether we can live on Mars, but whether we should. Ethical considerations and the potential impact on both Mars and Earth must be carefully weighed. As we venture further into the cosmos, we must proceed with caution, responsibility, and a deep respect for the unknown. The exploration of Mars is not just a scientific endeavor, but a moral one as well. The future of humanity may very well lie among the stars, but it's up to us to ensure that we tread lightly and wisely as we take our first steps on the red planet. Our actions today will shape the legacy we leave for future generations.